They moved the voting spot from last time, right, last year. The only spot I saw to vote in Tulare this year was. The Tulare Memorial. Place, it was the drop off spot, and there was a long line of people. I've always had like neighborhood houses and fucking churches right near my house that did it. Kinda weird. Alright, so, as I was saying, we're gonna do one section today, and that section is 10.3. I will adjust the homework schedule and I will adjust the syllabus tab. I'll show you on Canvas in a second. Probably not tonight, but this week. This is a one population mean test. And I usually call this the one mu test. What we're doing here, H naught is about mu. So mu equals some value. And then HA will be mu doesn't equal, is less than or greater than that same value. Which is our new step one for the hypothesis test. Everything else will remain the same. As a reminder, step two was get alpha. Step three was our test stats and p-value. Step four was the decision-making process. Decision time. And step five was concluding statement about HA. In the decision time, we were comparing p-value to alpha. Is p-value less than alpha, or is p-value greater than or equal to alpha? Criteria. As always. We want a normal distribution. If that is not specifically stated. We need some requirements we've seen before. We need. It to be a simple random sample. Or use simple random sampling. You are shitting me. Another political call. Are you fucking kidding me? Like. Yesterday should have been the last day they should have been calling, not on the day of.
Text message too.
I have not gotten any yet for today. Oh, wait, my phone's been sending them to spam, that's good. Forgot about that. Simple random sampling, they should be independent. Like if you're surveying people about how their household is, you shouldn't ask a husband and their wife that both walk up at the same time. That kind of thing, that shit doesn't happen, you don't want that. You want n to be greater than or equal to 30. And you don't want to have outliers on a box plot. That kind of skews up everything. On the final, you'll be able to assume that everything has a normal distribution. You're not gonna have to worry about this stuff on final, but I'm sure on the homework, they're gonna ask you questions. The way we find our test stat and p-value. In StatCrunch. Stats. T-stats. 1 second. You guys ready for some examples? Everyone looks so thrilled. We were so ready. Alright, if you have your computer here and want to see what I'm pulling my stuff from. I'm gonna tell you what page it's on, in the file section. There is a Math 21 lecture notes document. So enable that. In fact, for the rest of the semester, I'm pulling a lot from here. 21 lecture notes, and I think it says, let me get the exact name of it. In fact, I'll show you real quick. I gotta make sure I change the zoom. I'm going on files. Math 21 lecture notes in class. It's that thing. And I'm looking at problems on page 117 and 118 today. But I will, for those of you without I have a computer open, I will write down what the problems are. It was 117 and 118 today. All right, first problem. Assume the resting metabolic rate. Which we will call RMR for the rest of this problem. Healthy males. In complete silence. Is 5,710 kilojoules per day. This is a measurement of energy expended. Energy expenditure, kilojoules is an energy unit. Researchers measure 45 healthy males. Who are listening to classical music. So not in complete silence. And found their RMR. To be 5,708.07 kilojoules per day. On average. Okay, that's not each person individually, that's the average. With the standard deviation of 992.05 kilojoules. At the alpha equals 0.05 level of significance. Test the researcher's claim. Is there evidence that the mean RMR of healthy males listening to calm classical music I guess I should add that in up here, calm up here. Is different than. That of complete silence. I might have changed the words a little bit, but that's the gist of the problem. And if you're looking at the lecture notes, I think it even has it worked out, but we're gonna work it out for ourselves. Now, everything about our criteria seems to work. We're going to assume that they use a simple random sample. Even though they didn't say it. Independent people, independent males. We're not like brothers and shit. N is greater than or equal to 30, so that checks off. And we're going to assume no outliers, it doesn't say. But that's what we require, so we're gonna assume that was the case. So we're gonna go through our 5 steps of our hypothesis test. We have step 1. H naught is the statement of old stuff. HA is what the researchers claim. Researchers claim it's different is not less than, not greater than, but just not equal to. It's gotta be the old rate, not the rate that they found in their sample. The old rate was the 5,710. Step 2 is given to us. Alpha equals 0.05. Step 3, we need to test that. And we need a p-value. And for that, we're gonna have to go to StatCrunch. For StatCrunch, they are going to want X bar, sigma, and n. X bar was the sample rate, 5708.07. Sigma was the 992.05. And n was 45 males. Everyone looks like they're done writing, I'll switch over. I don't wanna rush anyone, we got time. We will definitely be done super early. Since we're not gonna do 1.1 today, but. Oh, we'll find out if it's 5.5 or not. Probably 5:15, we'll see. Alright, everybody looks like they're done scribbling. Let me switch over. Here's StatCrunch. Is StatCrunch website. We're doing stats, T-stats, one sample. We do not have individual data, they didn't tell us the individual 45 measurements. So we gotta go with some. And these are the values we needed conveniently, which was by chance. I put them in the order that they asked, what's going on? Wow, sorry, I got it, look at it. It remembers shit I did before, that's convenient. Why is that so big? X is super big in there. Huh, oh well. We are doing a hypothesis test and our mean was 5710. Always check your symbol on the HA, make sure you have the right one. If you understood everything that you're doing and you're doing the homework and you get the wrong answer, it's probably that, you probably didn't change the symbol when you needed it. We will click compute and it gives us the test stat. We'll just write down 3 decimal places. And I'll write down my p-value is 0.9896. And now we'll go back over and finish the rest of our project. All right, step 4 is comparing that p-value to alpha. This is our decision step. So p-value was 0.9896. Alpha was 0.05. Is the p-value less than or greater than alpha?
Greater than?
Greater than. Thank you. So this is the case of the not too low. It's either too low or not too low. So this is not too low. Which means this is our nots. Do not reject H naught. Do not support HA. And there is not enough evidence. Everything's got not it. If you got the greater sign. Our statement of conclusion is about HA. So conclusion. Can we support or not support HA? We're not supporting HA. There is not enough evidence. To support the claim. That. And I'm gonna go up here and I'm just gonna find where the claim was, and if it's in a way that I can just hijack it. Copy and paste it, I will. If I put in not enough evidence to support the claim that the mean RMR of healthy males. I can copy this question right here and not phrase it as a question. There's not enough evidence to support the claim that the mean RMR. Of healthy males. Listening to calm classical music. Is different than that of complete silence. And then I'm gonna go in and mention the fact that we did this at alpha equals 0.05 level of significance. Cause like to people that are reading your shit, that matters, that really like changes. How much error margin you have. If we had alpha equal 0.2, we have a really large error margin. But 0.05 is small, it's 5%. That one is the only step that's gonna change. All these other steps are the same, get alpha, find the test stat and the p-value. Try the p-value to alpha and make a statement about the HA. You guys ready for another? Trying to finish your writing, but yeah, I see something still on. Alright. Next question is on the next page and it is about points. State quarters. Page 118. The mean weight of quarters. Is 5.67 grams. So, but state quarters. Have different images on the tail side. Does this affect the mean weight? So I'm paraphrasing what the question is on example 2. Researchers want to know if it's different. Using the data from the 18 quarters below. That's their claim. Yeah. Alpha equals 0.05 level of significance. And I'm gonna say and also at alpha equals 0.01 level of significance. But we won't write the test 2 times, we'll just do it 2 different ways. Now, I haven't written down quarter yet, weights yet, yeah. You'll see. I already know what the p-value is, and so having these 2 alphas are gonna show you 2 different scenarios. So the weights are of the 18 quarters. I have. Easier for me to read. I've got 5.70. I've got 5.67. 5.73. 5.61. There's 18 quarters, so I'll do them in groups of 6. 61, 5.70. 5.67. 5.65. 5.62. Another 5.73. 5.65. 5.79. 5.73 again. 5.77. 5.71. 5.70. 5.76. 5.73 and 5.72. While you're writing this down, I'm gonna go get them entered into StatCrunch. Alright, you guys, let's see. We should start doing the test here before I switch over. So what are we looking for? We need to know that. Step one is gonna be identifying our H naught and HA. H naught is gonna be the equal portion to. HA is gonna be the researchers are claiming it's different. Again, they didn't say less than or greater than, so we're gonna go with not equals. And the weight we're comparing it to is the only mean we have listed, the 5.67 grams. We are going to do step two. We've got alpha equals 0.05. And we're also gonna look at alpha equals 0.01. Step three is gonna generate two different stats for these, and we're gonna get them at the same time. P-value here. And we'll do, I think it's the T-stat is what it's called. And P-value here. Just prepping some room to write down. Everybody ready? Good. Alright, I got my coins here. And I think I copied and pasted and I had to do some adding and transposing. I think I have them all. And just checking them all real quick. And 77, 71, 70, 76, 73, and 72. Okay, I got them all. So we're gonna go stats, T stats, one sample. Now we have data, we don't have the summary. We could do summary if we wanted to, but we'd have to go get all the summary stuff. And I'll show you how to do that in a second. We're gonna go with data. And we're saying our hypothesis was 5.67 grams. And that looks weird with the zero, so I'm gonna get rid of it. I don't know why I wrote test stat and p-value down twice. Well, I don't know what I was thinking. It's only gonna be the same thing, but might be helpful to see them next to each other. We click compute and we have 2.753 is our test stat. And our p-value is 0.0136. Well, I guess I didn't have, I thought I was just looking. I don't have the right thing listed down, God damn it, I have the wrong p-value. We'll only do the alpha equals 0.05 for now. We'll do the split one on the next one. I know, I'm just fucking unreliable, right, Alfredo? Or we can do alpha equals 0.001, there we go. We're gonna do that. Alright, let's go back. Are I using the same alpha they used? I changed my alpha up. I got the same alpha. So we're gonna do it at alpha equals 0.001 for the second one. This will show what I want. Since Alfredo was looking, I've let him down yet again. It's a perpetual series of letdowns for him. Now we know how his wife feels. He's like, I got evidence of you now abusing me. It's on camera. I got you, Jones. Alright, step 4. Decision time. We're gonna compare our p-value of 0.0136 to 0.05. And we're also gonna compare it to 0.001. And we'll show how both of these end up turning out. So on the left one, p-value is less than alpha. So the p-val is too low. Reject the hope. And support HA. There is enough evidence. And over here, p-value is greater than alpha. So not too low. Do not reject H naught. Do not support HA. Not enough evidence. So step 5, I'm gonna write this as a split thing. I'm gonna say there is. I'm gonna say enough evidence. Using alpha equals 0.05. Or not enough evidence. Using alpha equals 0.001. To support the claim that state quarters have a different mean weight than regular quarters. From the basic quarters. Now, you would not put this in one sentence. I'm just showing like this is 2 ways to write the sentence. If we had alpha equals 0.05, we would cut out the bit about not enough evidence. We would say there's enough evidence to support the claim. And then if alpha was the other one, we would cut out the top part. And we would say there is not enough evidence to support the claim, depending on which alpha we use. That alpha decision can sometimes really like be the tiebreaker. So like choosing the right alpha, really 5% or 0.05 is standard. You really only need to go lower if it's like really fucking important that you're not fucking wrong. Does that make sense? A little bit. Like if we're talking about like surgery that can kill someone, you don't wanna be wrong, right? If we're talking about stopping the vending machine, who gives a fuck? Right, the vending machine company does, but even then, it's if they're wrong. They just lose a little bit of money and they can fix it, they haven't killed anybody. Whereas a surgeon, you're fucking wrong, fuck shit up, someone's dying. That's just coincidence here. This is not related to fucking Lysol. Alright, I guess. Let's talk about statistical significance versus practical significance. What page is this on? Page 120. So what the idea here is. When n is large. Really large. And we get a p-value. Less than alpha. Well, that's just when n is large. When n is large and we get a p-value less than alpha, we say it's statistically significant. I just fucking mangled that. Statistically significant. But. The sigma we use is sigma over the square root of n, basically, effectively. And so when n is large enough, like when n is super large. We can show something. Is statistically significant. But not really. Significant in a practical sense. The idea here is like when n is like a normal amount. N is normal. We're looking at like a 95% range like this. And we're looking at our outliers out here. Alpha is out here or out here. When n is super large. Our curve becomes more like that. And that 95% window is now super fucking small. And we can have a value that's really actually really close to the mean. But still be outside of this 95% range. And the p-value test is gonna show, the hypothesis test is gonna show it's not significant. So like this is the true mean and our sample mean is here. It shows as significant. So we would reject H naught. Support HA. But in all reality, mu is super close to X bar. As you'll see, when we do an example, you'll see. That's the idea of what's going on here. So our example that we're gonna use is in 2003. The average age of mother. Let's say mom, just to make it shorter. At the time of the first childbirth. Was 25.2 years old. To determine if this average has increased. Researchers. Sample 1,200 mothers. 1,200 mothers. And get. X bar equals 25.5. Sigma equals 4.8. And we're gonna test their claim. That's not really sigma, that's S. It's the sample, it's an S. So we're gonna say H naught equals the old value. HA is, did it increase? Has it gone above that value? And it says alpha equals 0.05. I didn't write that part of it down, but this is on page 120. Step one is that. Step two is right here. And we'll come over to StatCrunch and put this in a second. Set up what we're gathering now. Step three is test that. And p-value. Compare that to alpha. Everyone ready? So we're gonna go stats, T stats, One sample, we have summary data here. Our sample mean was 25.5. Our standard deviation was 4.8. Our sample size was 1,200 people. We're testing against 25.2. And we're looking for greater. All right, I'll hit compute. I get a t-stat of 2.165. And I get a p-value of 0.0153. Okay, so. In step 4, we're gonna test that claim. Is p-value less than or greater than alpha? It's less than. So in this case, we would reject H naught. Support HA. Which says. The average has increased. Without doing the whole sentence, the average has increased. But. It went from. 25.2 years old. To 25.5 years old. 3/10 of a year, that's like 3 months. Is that really, would you argue that is a really a important difference in age of mothers? No, they're still 25. If we ignored the months, they're still 25. So like. Sure, this says it statistically has gone up. But if we had only done like 50 people. It probably wouldn't have. In fact, we'll go look at 50 people and see what it says. So this is, yeah,
Like, and like 45.8, would we round it off, and then that would be significant? Or,
well, it says statistically significant, it's your decision whether or not it's practically significant. If you think 25.8 is significantly different than 25.2, then yeah. It's over a half a year, so maybe. But this is really close, it's only a couple months. That's the idea of statistical versus practical significance. When you look at the two means, you're like, that's really quite close. You know? In fact, let's go back and see what happens if we change n. I'll redo it, stats, t-stats, one sample with summary. We had 25.5, 4.8. Why don't we say 40? And we're doing 25.2 and greater than. And And now we get the p-value of 0.3474. That's bigger than 0.05. And so we wouldn't reject it. So because we chose n to be so large. It really shrunk down the standard error. The standard error here is, that's kind of like this, the new standard deviation. This with the 1,200 people was that. With the only 40 people or whatever the hell I said here, it's that. And so it's caused our p-value to shift a lot, and now we wouldn't say reject it. We'd say, no, it's still 20, it still hasn't changed. Does that make sense? Okay. Does anyone have any questions? Yeah,
So. Or does that just vary?
you want at least 30, 50 to 100 is usually pretty good for most things that you would do as a student. Going a couple hundred still isn't bad either. Getting up into the 1,000, like we had 1,200, that's excessive. And which is good, that in a sense, because you're not wasting your time collecting so much fucking data, because it kind of makes it unrealistic. Unrealistically small window of error. That's it for 10.3, I will adjust the schedule, if you haven't voted, go vote. Or don't. It's up to you. What the fuck out, UTFO, there, I feel better. If I don't say it, I feel like dirty inside, like I just give you of the experience that is John's.